So in this video we're going to fill in the last of the missing examples of the complex numbers section, and the example is looking at a complex number 2 over 1 plus I and raising it to the power 14. So this is going to be an application of de Moivre's theorem, and the example is on slide 322. So the first thing we need to do in this example is to write the complex number in exponential polar form. And if you think about what's happening here, this is actually quite an easy one. So on the top, the numerator is just the number 2. So if I write that in exponential polar form, it's 2e to the I 0. And the denominator is 1 plus I. So that number's about here. And if we think about writing that in exponential polar form, the modulus is just root 2 and the angle is pi on 4. So if I simplify that using the rules that we have for quotients in exponential polar form, I can leave this out the front as 2 over root 2, and then we just subtract the angles. So it's e to the I minus pi on 4. So all I've done there is written the complex number in exponential polar form, and now I'm going to use that to find out what the 14th power of that number looks like using de Moivre's theorem. So remember, what we had to do is we take the modulus of the complex number and we raise that to the power 14, and then we take the angle and we multiply it by 14. So this is just 2 to the 14 over root 2 to the 14 e to the minus I 14 pi on 4. So we can simplify that a little bit. So root 2 to the 14 is just 2 to the 7 and 2 to the 14 on top, e to the minus I 7 pi on 2. And we want to put this back into the range of angles that we prefer to have. So minus 7 pi on 2 is just the same as pi on 2. And 2 to the 7 is just 128. So if I think about what this looks like, so 2 to the 7 is 128. And if I go around pi on 2, then I'm just on the imaginary axis, so that this part of the complex number is just I. So the answer is 128I. And that's it.